Okay, welcome everybody. This is a session on serverless design patterns, rethinking your traditional enterprise application approaches. I'm Robert Grote. I'm the EVP of Technology and Strategy at Smartronix. And we have one of our greatest customers, Fannie Mae, and Bin Liu, who's also going to be talking to you about their particular use case for doing advanced enterprise workloads using serverless computing. So today we're going to talk about what is serverless. You guys have probably been bombarded with it at this conference and previous conferences, but we're going to at least level set everybody on what it is. Talk specifically about what is AWS Lambda, how it can be used, and sort of how it was initially traditionally designed to be used, and really how it could be used in a rethink kind of approach. Give you some reasons on why you should care about using Lambda and why it's kind of an important new capability. And then we're going to go right into what Fannie did, and then at the end of all of this, you guys will have total enlightenment about serverless computing, so you got that going for you, which is nice. So just real quick about Smartronix, when Teresa mentioned that at the very first GovCloud there was 50 people, I think 4 of them were people from Smartronix trying to really get a better understanding of AWS. We've been a premier partner with AWS for 5 years, pretty much every competency that there is. We were actually kind of had a little bit of a claim to fame by being the first company to help bring the federal government into AWS back in 2009 with recovery.gov. So let's just kind of level set on what the AWS Compute Services overview and what the capabilities are. You guys are familiar with EC2. That's really the virtual machine that you have. That's at the infrastructure and the hardware layer. And then if you go a little bit further down the stack, you've got the EC2 container services, which is more of a way to manage Docker containers, and you're looking at things kind of at the application layer and the OS layer. And then when you look at Lambda, you're really talking about functions. You're talking about things at the runtime level, and that's really what we're going to be kind of talking about the most today. To put Lambda simply, it's just being able to run code based on events without having to manage servers or manage server infrastructure. So what is serverless? I kind of like Werner's quote when he says, no server is easier to manage than no server. And that's really what we're talking about here. You don't have to manage the virtual machine. You don't have to manage the operating system. You don't have to do patch management, scaling, load balancing, availability, fault tolerance, provisioning, et cetera, intrusion detection, all of those things. And you only pay for what you use. And that's really kind of a critical component. It's really the new value proposition with cloud computing is when you can go deeper into these native services, there's less things that you have to manage and operate, and you allow the system to manage and operate them for you. All right, so it sounds a little bit too good to be true. So with Lambda, what are some of the limitations? We wrote this slide maybe 3 or 4 weeks ago. And half of this is wrong already. This is how fast the pace of innovation is with AWS and what they're doing. You'll see things like limited function and code size of 250 megabytes. We've learned that that's changing. You've heard about maybe there's only a 500 megabyte temp directory. You've heard that's changing. The runtime, when we initially started doing this, Ben, I think it was 180 seconds or 100 seconds. It's already at 300. We're hearing about that potentially changing. The size of the memory limitations that you have for those particular functions of code. And this almost seems ridiculous to me because, I mean, we all remember the famous Bill Gates quote about, you know, you should be able to develop whatever you want within 640K of memory. Now we're talking 1.5 gigs of memory for a single function call. That number is going to be changing drastically, and we've seen it increase quite a bit just since the launch of AWS Lambda. And then you have a limitation of 3,000 concurrent function executions, and we're going to actually show you that that limit can be substantially increased as well. And a lot of the limitations, such as asynchronous and stateless, it's the way you design things, and you can actually design around some of these limitations, and we're going to talk a little bit about that and some specific use cases associated with that. So it's kind of weird to say traditional with Lambda, but if you kind of think through why AWS created the function as a service type capability, you want to be able to have event-driven code. You want to be able to do dynamic event handling. And there's a lot of use cases for that, for doing things like File processing, somebody uploads an image, you want something to automatically be handled based on that event. You've got scheduled event processing, traditional even batch computing processing where you're doing scheduling events. You actually have the ability to create stateful, mobile back-end services, RESTful endpoints for your code. You've got the ability to handle streaming event sourcing. Look at your DynamoDB tables whenever they get updated. You can process events based on that and have these kind of secure REST endpoints. Now the rethink stuff, the transformative stuff, is actually really, really powerful. One of the things that Smartronics initially latched onto is this idea of autonomic security remediation. Things that cause events within your cloud computing infrastructure can then immediately be handled with a Lambda function. I'll give you an example. Somebody launches an instance. Maybe that instance has been tagged for ensuring that the root volume is encrypted or something like that. As soon as that instance is launched, you can write a function to validate some of your security and compliance requirements and make sure that those requirements are met and stop the instance from even being launched or quarantining that instance. Somebody changes a security group role. As soon as that security group role is changed, you can have a set of functions that can actually help you look through whether or not those meet your security and compliance mandates. That's really powerful. When you think of some of the greatest value of the cloud, in my opinion, it really starts with the transparency that you get with what's happening in your environment. You don't have that level of transparency in an on-premise infrastructure. Every single thing that happens in your cloud environment is a web service call that's logged, that's tracked, that's traced, that can have event-based processing associated with it. Other interesting use cases. Imagine being able to run a website for 49 cents a month. You can have your content out in S3. You can have simple back-end processing for function calls routed through an API gateway that specifically call your Lambda function, and you only pay for the execution time of that particular function instead of having a server in the background waiting for your calls. Dynamic log analysis, hooking up the stream, seeing everything that's happening in your environment, responding to IoT events. And then, of course, an obvious one is massively parallel processing. And that's the Fannie Mae use case. And that's the case that we're gonna highlight here. But it's interesting, when we started to think through the multitude of ways that you could use Lambda, we didn't just say it's only gonna be appropriate for these particular use cases that they were designed for. You really need to take a step back and think, how can I look at my application portfolio? How can I get better value out of cloud native services and maybe do something really bizarre like we did with Fannie Mae? Oop, I'm sorry, I thought I had. We'll go into the way we solved it. Perfect. Sorry about that. So how would you have done this in the old school way? Their problem was they needed to run quadrillions of cash flow simulations on tens of millions of loans every month, and each time under various economic models to determine the risk. So one way to do that is build out a massive grid computing infrastructure. Make sure you have enough capacity to meet your peak requirement. If your grid computing infrastructure, say, needs 1,000 nodes, better have 1,000 nodes readily available, regardless of how much you're using it. Go ahead and pay the big vendors the license cost for your grid control platform. And then build out a very expensive server and storage infrastructure with a huge management burden, inconvenient utilization, and overspend to meet your business goal. Or, circa 2016, way back then, you'd have your engineers go, wait, let's just move it to the cloud. Let's take exactly what we did on premise, but let's move it to the cloud because maybe we're going to get better capability to match capacity to demand and maybe lower some cost. Of course, you're still going to have to license your expensive grid control platform, and lift and shift sounds like the easiest and quickest and best thing to do, especially if you want to take all the problems you had in your on-premise infrastructure and repeat them in a cloud infrastructure. Lift and shift is perfect. Somewhat less expensive server and storage infrastructure, still a high management burden. You're still doing the same processes, the same things that you had to do in an on-premise infrastructure. You're still physically managing assets in the cloud environment. It's better, but it's not great. Now, we can go to what Fannie did. Here you go. Yeah, grab that for you.
Thank you, Robert. My name is Bing Lu. I'm Director of Risk Modeling and Analytics at Fannie Mae. Today, I'm going to talk about high-performance computing using AWS Lambda for financial modeling. So here, I'll give a brief introduction of Fannie Mae business. Fannie Mae is a leading source of financing for mortgage lenders. We provide access to affordable mortgage financing in all market conditions. We manage and reduce risk to our business, taxpayers, and housing finance system. In 2016, Fannie Mae provided approximately $637 billion in liquidity to the mortgage market. We enabled 1.1 million new home purchase, 1.4 million refinancing, and 0.7 million rental housing units. Fannie Mae has approximately managing about 20 million mortgages, and the portfolio size is about $3 trillion. Financial modeling is a multi-color simulation process to project future cash flows. We use it on a daily basis for managing the mortgage risk. We use it for underwriting and pricing, risk management, financial reporting, loss mitigation, and loan removal. Each month, we generate more than 10 quadrillion cash flows in hundreds of economic scenarios. High-performance computing grids are the key infrastructure components for financial modeling at Fannie Mae. Our current environment no longer meets our business needs. It is 7 years old with limited non-elastic compute capacity, storage, and I/O capacity. It is very costly to refresh the servers and storage, and it has very complex API for distributed computing application development. Typically, it takes more than half a year to add incremental compute capacity and develop any new application. So we're looking for new facilities that allow us to react to market change quickly. We want to have access to unlimited compute resource and unlimited storage. We want the facility to be simple and to manage. We want to have a simple distributed computing API for application development. And we want to be able to reuse the existing code and allow us to deploy the new solution quickly. So we also want to reduce the operation burden and enable the innovation. And most of all, we also want the facility to be cost effective.
So the journey started with Fannie Mae reaching out to AWS with that problem. It's a pretty simple problem. 15 quadrillion cash flow, near infinite capacity, cost to completely match demand, highly available, highly secure, no problem. Call in Smartronics, no, just kidding. So, but what we did was we looked at it and we considered a lot of different capabilities. We thought through the lift and shift model. We thought through even containerized services for this. Could we actually encapsulate that application and be able to use a clusterless, maybe next year's topic, a clusterless model, a management model, where we could actually utilize container services. And then when we looked at the discrete nature of the code, we had kind of this aha moment where we realized that we could probably very quickly just refactor this application and build some of the glue and constructs around it and use the fact that it's already got event-driven capabilities, it can nearly infinite scale, all the output, there isn't going to be I/O contention, there isn't going to be all of these components by really looking at that. And I would say that the code refactoring bin probably was maybe a 2 to 3 month effort, maybe even for the proof of concept even shorter than that, just to show that we could take it, put the right wrappers around this code, and be able to run it in Fannie in AWS infrastructure. And then in March of this year, we were actually able to deploy the first financial modeling application to pre-production, and it ran on 15,000 concurrent instances. And I think within the next couple of weeks, we're talking about moving this to production. So what does that reference architecture look like? Well, if you think of a traditional HPC environment, you've got a lot of different components. Obviously, you have the input. In a traditional environment, this might be a massive storage platform that you're using. For us, we have that inputs come in through S3. Now, we did need some things to do the orchestration that you would have in a typical grid model. You needed to be able to take the data and what we call a splitter function, which is just event-based when the input file comes in, ingest that large input file, and then split it into the different economic scenario files that you want to be able to run. Now that event of being able to split it and write it to S3, what did we learn earlier? You can do it a source mapping, an event mapping, that when a file gets written to S3, S3 launches a Lambda function. So as soon as that splitter function writes stuff to S3, automatically in the background, that code is provisioned and runs and executes and does a tremendous ramp up. So you see the Amazon S3 event, you see the Lambda function mappers, and then each one of them is independently running as its own simulation and then writing to S3. That allows us to do near infinite capacity, near infinite IOPS in terms of writing to the storage infrastructure. And then once we have all of that data, we can write a simple reducer function that can aggregate that data, compose all of that information, again, with the result written back out, for us to do any kinds of analysis on that. In the future, if they want to do MapReduce, if they want to do Athena queries on the data, if they want to do all the component, the data and the output is now in a readily available fashion for them to be able to do the analysis. So what were the results? Initial burst rate, imagine that. Within 5 minutes, we've got 3,000 concurrent functions. And initially, we worked directly with the AWS Lambda team to help kind of continuously improve the performance. We were getting up to 240 more functions writing per minute. And at the max, we were able to get all the way to 15,000. So we ramped up from 3,000 concurrent connections to 15,000 concurrent connections. And Ben's going to talk a little bit about what the application results ended up being.
So here is our application result. We ran the entire Fannie Mae portfolio, which is about 20 million mortgages. It takes, for a specific economic scenario analysis, it takes about 1.5 hours. This is 4 times faster than the existing process. The performance doesn't degrade during the ramp-up period. It shows that there's no I/O bottleneck. Typically, for large-scale distributed computing, you're limited by I/Os. So as you can see on the chart, that the number of Lambda concurrent invocation increase linearly as a function of time. So the Lambda efficiency is also very close to 100%. And so how do we measure that? So basically, we calculate the expected elapsed time based on Lambda billing time, and then compare with the actual elapsed time.
And that's tremendous when you think about that. Now, with this being a batch run that used to take 6 to 10 hours in an on-premise infrastructure that was in a single data center, didn't have the high availability that the cloud can provide, 4 times faster, 1.5 hours to run the entire economic scenario. What does that mean? You could do now in the same period of time more complex scenarios. You can run more economic conditions. You can hone in your risk values a lot better than you could. And you don't have to spend time managing server infrastructure, managing storage, troubleshooting I/O, bringing in the advanced great computing guys to figure out where the hotspots are in the data, writing your code to help facilitate or remove some of the limitations in your on-premise infrastructure is not something that you have to do anymore here.
So I want to provide a little bit more information on our experience from Fannie Mae point of view, and Robert will summarize for general users about the advantage of using Lambda. So there are many benefits of using Lambda for high-performance computing. For Fannie Mae, first of all, it is cost-effective. We never pay for idle. The cost is based on actual CPU time, not the elapsed time or maximum processing capacity of the facility. Second, we are able to achieve performance at zero cost. The cost of running one Lambda for 15,000 hours is the same as the cost of running 15,000 Lambda for 1 hour.
That's amazing.
That's indeed is very amazing that you cannot never achieve this scale of economy for using on-premise cloud.
Yeah, and that's running one Lambda for 15,000 hours is the same as running 15,000 Lambdas for an hour. I mean, that's kind of mind-blowing when you think about it. When you look at the cost and you look at, as they want to ramp up, they're going to linearly get the same value by being able to provide that capability. So if you look at a traditional enterprise application, you look at an HPC grid, you have kind of a sunk cost with idle or constrained capacity. Unless you're using that thing 100% of the time, then you're getting the full 100% value out of it when you're on your on-premise infrastructure. Chances are, if you're using it 100% of the time, there's somebody waiting for something that they wish they weren't waiting for, right? So you have some user demand issues, you have some user expectation issues. In a serverless environment, let the cloud automatically scale to meet your demand. When you look at either building one of these environments or you're in a refresh cycle for these environments, these are millions of dollars to create 1,000 core, 10,000 core, 10,000 node infrastructure. As Ben mentioned, you're paying per use and you're paying for the actual CPU usage. If you've got a research facility or you've got somebody who wants to look at doing this modeling and simulation, they can't even test in an on-premise infrastructure until you've bought that 1,000 node infrastructure. What you can do here is you're going to allow yourself to fail fast and run through these scenarios. So you're talking, Ben, I didn't know if you wanted to go too much into cost, but in general, for a 20 million, 1.5 hour, 15,000 node simulation run, on average, what do you think the cost is to make that single run?
So for Lambda, for that typical run, it costs about $1,000. But if you were to invest on-premise infrastructure, you would have to pay upfront, and it is about $20 million upfront.
Yeah, let's rent a 15,000 concurrent session compute environment for $1,000 for a run versus investing 20-some million in an on-premise to see if your solution will work. Again, this whole rethink really has to consider what the total cost of ownership is, what the ability that you can get, the agility that you'll get from being able to try new things in the cloud and be able to experiment and fail fast in these environments. High maintenance burden versus a fully managed service. Performance constrained versus horizontal scale. You're limited by the capacity of what you have in your on-premise infrastructure. And you have to design and build your on-premise infrastructure for that peak level, or else you're going to have failures in the environment. And it's really hard to match the utilization. Ben, you were talking before the amount of time that it took you to add capacity, sometimes 3 to 6 months.
Correct.
I see a lot of federal customers in here. I'm sure that's something that you've heard. It's months, if not several months, to procure infrastructure.
And especially, so our infrastructure is 7 years old, so there's lots of versioning issue. And up to a point, we would not be able to add new capacity because it's out of service life, and we would not be able to find compatible hardware.
Yeah, and this isn't just adding server infrastructure. This is adding server infrastructure in a government dedicated region that meets your FedRAMP requirements that can scale up to 15,000 concurrent sessions. I mean, that's just a tremendous capability. Were there any additional license fees that we had to pay? No. Are we able to more rapidly build and deliver new capabilities? Can we have a new pipeline for being able to do continuous integration and deployment capabilities at low complexity? Yes. And instead of having that massive compute running maybe 30 to 40% of the time for doing these grid computing applications in a single environment, now you have high availability. Now you have that ability to really run it. When you talk about the footprint for the code and copying the data over, you can run this in any region that you wanted to run, but you certainly would have the high business resiliency by running it even within a single region. So in summary, I'm hoping that some of you guys were somewhat enlightened by thinking through what cloud native means. We have a propensity to look at how we've done stuff on premise and get excited by the cloud because there's cost advantages of moving to the cloud, or there's some agility in being able to do things rapidly in a cloud environment. Sometimes you want to rethink and really get the value out of your cloud service provider by looking at what the native capabilities they have around platform as a service or things like functions as a service within the AWS model. It's real important when you're looking in that very early design phase where you're maybe considering a significant migration into AWS. And you're going through that discovery process, you're doing the application rationalization, you're profiling your applications. Just don't boilerplate it and say, well, this is how it runs on premise, this is how I think it should run in the cloud. Take the time to rethink, are there things that we can do more natively in a cloud environment that's going to reduce our operational burden, it's going to make it easier for us to manage this and provide innovation and new capabilities. Traditional approaches can hamper your cloud adoption. It used to be we'd have a great conversation with the customer base, and they'd say, this is awesome. The next day I'd get a spreadsheet and an email that said, here are all the servers, here are my specifications, how much is it going to cost to run into the cloud? And there's so many more things associated with that. You really have to understand how the cloud works, how you can take advantage of some of these native services and really get value. And don't be afraid to refactor your application. Try. I mean, if we had failed in the first 30 days, it wasn't that much of a cost to Fannie for them to find out if this could work. Now they're talking about being able to do a run for $1,000 a run versus potentially tens of millions for new grid computing infrastructure. New cloud development, new application development. Really think through the distributed nature of the cloud and the advantages that you can take through distributed architectures. Think about that from the start. And don't think of serverless as anything other than enterprise grade. You have all of that security capability, you've got all the accreditations from a FedRAMP perspective, you've got all the availability and integrity that you need in these environments. And the main thing also, stop doing a differentiated heavy lifting. I mean, we've been saying this for a long time. Your agency's mission, your company's mission, isn't dependent on how well somebody can go and fix a blinking light on a server, or how good they are at replacing RAID drives in a server. Just stop doing that. Think of the cloud as a new way for you guys to be able to reduce that operational burden and get value. Focus on your code and not your infrastructure. So I think we're going to take questions. Great. We got a mic right here.
One of the concerns I have is making sure you test the security controls. Mm-hmm. Okay, you talked about FedRAMP.
Correct.
So those have security controls. So how do you do the serverless and ensuring that you have met your security controls?
Great. So when you're looking at endpoints that can be called in the cloud, you're thinking through how can you protect those endpoints? How do you create the boundary around that infrastructure? How do you define that boundary? How are you going to do identity and access management for being able to access this environment? And again, the AWS Lambda uses the same IAM capabilities that you would have in your own AWS infrastructure. It can integrate with your existing directory services. It can federate with that. You can do role-based. You can do privileged user access management within those environments. You can secure those endpoints. That's a big component of the access monitoring. Every single call also can be audited. You have CloudTrail events, you have CloudWatch events. You have these components that allow you to know how the service is being utilized. You can put cost controls, which I know you were just talking about security, but I'm talking about in general, how do you do the governance, how do you do the controlling of the infrastructure when you're talking about an infinite capacity? You want to put the cost controls in place. You want to put the security controls in place. You want to put the alerting in place. You want to feed the alerting information, the event information that's happening in that environment, maybe even to your traditional SOC environment that you have. You have that ability to ingest these logs in the same manner that you could do in an on-premise infrastructure, but you have full transparency into what's happening on that infrastructure. So protect the boundary, protect the account, protect down to the endpoint that these are running. Anthony, anything else that you can think of? So what Anthony was saying that you might not have been able to hear, you have role-based access to every component in this. So when you're talking about how you're going to do the inputs and outputs, how you're going to monitor to make sure that that data, you have the integrity of the data and that you're making sure that that data isn't exposed, that's a key part of this. For a lot of these systems, they end up being closed systems that don't even have internet endpoints. So you can connect them to your environment and really carve out a kind of a virtual private cloud that allows you to have this capability within your boundary. So one thing that he mentioned was when you're talking about taking sensitive data and you're pipelining it through a system, the ways that you can protect the data are kind of already baked into some of the cloud controls. So what you don't have necessarily in a grid environment on-premise is who has accessed it, when it was accessed, what account accessed the data, was there anything done to the data from a put, copy, delete, or altering standpoint. You have full transparency and full visibility into every object of data that you have in your environment.
Yeah, hi. On your architecture slide, you had EC2 being used to split the input file.
Yeah.
Could that have been done also with Lambda? So you never have to use an EC2 instance at all?
We thought that so we're talking about 20 million. So the question, in case everybody heard, was could we have used Lambda for the entire function, the entire splitting and everything? Yes, we could have. We could have even scaled that out if we wanted to. What we knew is you have a limitation with Lambda of 300 seconds runtime. We knew that it would take longer than that to ingest the data from the pipeline and do the splitting to do the fan out. But we also knew that the splitter function itself doing the fan out was going to be faster than AWS could even keep up the capacity. You saw 249 ramp up per minute. Well, that splitter can do a lot more than that. So it was really a function of the amount of runtime. This entire thing could have been serverless. And before, when we built this, we didn't have batch. We didn't have a lot of the newer capabilities that have been introduced as well. Yes, sir. Sorry.
Could you talk a little bit about how you manage your code deployment across potentially thousands of Lambda functions?
Right. Anthony, do you want to talk about it? Because Nick isn't here that built it. Or Ben, are you familiar with how we're doing CI/CD and code deployment?
AWS offer the code pipelines service, and specifically for Lambda, there is a function called SAM, and so you integrate the SAM into your code pipeline for CI/CD. So these services are all available. Fannie Mae,
we tried to use as many native services as possible with this, but maybe if we get your information afterwards, we could share more details with you on.
Just real quick, you can say how the SAM access each one of those Lambda functions or a single batch of code.
Okay,
So,
yeah.
All right, so the SAM function for Lambda, every time you update that function, each one of those simulations is a specific function of code. So they're only updating it a limited amount of times. So every time there's a CI/CD process, the SAM function automates the update of the existing Lambda functions.
So basically, AWS service they're not just providing a single service, they provide an entire ecosystem. So the related functions that you need to support your application is also there. But this is a little bit beyond the scope of this conversation here.
But I'll be around afterwards too to give you some more detail as well. Yes, sir.
So I have a slightly different spin. I have to preface it by saying this is a really good, different view, and I appreciate that. But to play devil's advocate, the question I have putting on my big data hat is, what's the comparison to, say, for example, using an EMR?
Right.
Because it looks like here you've done your own, you've done your own map and reduce, and rejoin
Okay,
function.
so I can take this question. So when we first started our journey to AWS, first of all, we tried infrastructure as a service, lift and shift. We tried that, and it's not cost effective. And second, we tried to use MapReduce to do the distributed computing. And there, it's a little better. We don't have to pay actual distributed computing licenses, which cost millions of dollars a year. So that makes it a little cheaper. But still, we have to manage the server. And so it's still not as cost effective. And it's difficult to ramp up to say, whenever I need something, I'm able to burst out to thousands or 10,000 of machines instantaneously. And so we cannot address our on-demand workload. So that we started our journey in early 2016. Certainly, Fannie Mae also has a very high information security standard. And it took us a while to build our standard and also wait for AWS to put Lambda inside VPC. That's our first step. And then we started to test it at larger scale. So from application development point of view, it's straightforward because there's no code to write. If you use MapReduce, you still have to write the code. And then from agility point of view, or in terms of ability to scale up, it scales up very quickly. And then, so from many perspectives, it enables us to react to change quickly, and also we don't have to reserve the CPUs upfront.
Absolutely.
We did try, and so this is the most, at this point, it's the most cost-effective and convenient service that we use. Certainly, if next year, if AWS comes up with new product, we're going to evolve. And this is not the starting point. Certainly, it's not the ending point either.
Right here, we have a question.
When I hear $1,000 for the production run, that sounds excellent, right? But that's not the total cost. How
Correct.
much did it cost to get this thing going? What was the AWS bill before the production run? Was that in the $10,000 range?
No.
$20,000 range?
So are you talking about development costs and testing costs?
When I do development when I'm costing a project and we're going to do all the development in Amazon, I got to estimate how much we're going to have to pay Amazon, AWS, for the developers to be doing the work. How much did it cost to get this going?
So when the developers do a run, they're only charged for the CPU usage that they're using also during the run. So let's say that they're doing some development and they're only running 1,000 simulations. Well, it's 1,000th of the cost. It's in the tens of dollar range when they're doing their development. So there is no big infrastructure around this that costs $10,000 a month. If they decided not to use Lambda for a week, the infrastructure charges are having the VPC up and some storage. It's in the hundreds of dollars. So that's it. There's no secret, production level cost or supporting cost. What's that? It's almost negligible. It's almost negligible.
So for high performance computing, 90% cost is in CPU usage, and the remaining, like we use code pipeline, we use S3. We also use RDS, Redshift for some data storage, audit trail, and those are all negligible comparing to the Lambda cost.
I think we have some time for more questions. I see one in the background there.
Okay, my question is about with the Lambda. I know there is some limitation that it runs for a maximum of 5 minutes. Is it true?
Yeah, right now it's 5 minutes,
Okay.
and
Is there any
that's increased from its initial launch.
Okay. So I see
and that's
this.
per running function.
Yeah.
So the function itself.
Okay.
Yeah, so if you need to chain them, obviously you can use step functions or build some glue around that.
Got it. Okay, so I see this Lambda as like a worker, but just takes a task and just done with it. So when you have this limitation of the time, when there is more workers to run, just in case you have to manage the state, just in case between the workers. What is the best design?
Yeah, that's a really good question. AWS has published some best practices on how to do state management. Obviously, you can use S3 as a stateful storage. We talked initially about using DynamoDB. So when we started a file run, we have a unique identifier for each simulation, and that just has to be mapped to some key value pair. And then there could be a cleanup function after that if that isn't done. What we found is that we actually could do more in that 5-minute period. So instead of just allowing a single simulation to run, if there was still time left after that one function would run, it would loop back and run another one. So within that 5-minute window, we were running 10 to 15 simulations.
Yeah, we actually package up to 60 simulations in 5 minutes. 60 simulation in this 5 minutes interval. So it does require some upfront thinking. And so using Lambda certainly removes the burden of coding distributed computing layer. But on application side, you need to think about how do you break down your application into smaller steps and fit into this and think through your workflow. And so there is a, basically this forces you to think in terms of distributed computing instead of parallel computing. So you need to be able to distribute horizontally.
Yeah, once you start thinking through design patterns where you can decompose things into primitives, then it's really easy to orchestrate across those primitives. And that's really kind of the AWS model for how they built their services internally. So you can sort of stitch things together as well.
Hi, what's the elapsed time from the event trigger to the Lambda function starting to run and process?
For us, this is not the critical step because it's a large-scale batch processing. And so we, as long as it completes within 5 minutes, we're fine. So basically, you have to design your process for the batch processing. Now you're asking about the response for interactive usage. Lambda actually connected to API gateway, and or you want to have a faster response API gateway or using DynamoDB, that will have a faster reaction time.
Yeah, so for typical applications where you want to have rapid response times, there's things that you can do to really facilitate making sure that that Lambda function is hot and ready to go. In this environment, they've got a significant amount of code library. They've got some temp file data that we didn't really even care that much about optimizing the initial spin up, knowing that we were going to have several thousand concurrent running. But there are a lot of ways that you could do to get the millisecond performance from the calls.
Are you doing this in GovCloud, and did you find any limitations of services there?
So when we first started, Lambda was not in GovCloud. It isn't a requirement from Fannie's perspective. Their requirement at the broader level was FedRAMP controls, not FedRAMP moderate, not that it had to be within GovCloud. Now that Lambda is in GovCloud and ready to go, we have a lot of potential models that'll be working in GovCloud.
So we've heard a lot of the good things that you guys have discovered by using Lambda. How about some of the bad things maybe that don't go well on these PowerPoints?
Well, the AWS people in the room, please just feel free to walk out or turn now. So this was a fairly new service when we started working with it. It wasn't built for some of the things that we were doing in terms of being able to scale out to 15,000 concurrent sessions. So there was some initial things where we were getting error rates, trying to really understand how to do it. When we first started, and this would just be with AWS S3 in general, when you're writing out to S3, there's ways that you can write out to S3 in a distributed manner so you don't have any kind of hot bottlenecks around that. So again, when you're architecting large-scale, complex systems at scale, there's some best practices around how you actually design the naming of the buckets to make sure that you can write effectively to the files. Those are some of the learning curves that we went through. Initially, trying to think through how you're going to write code that's going to run within a 5-minute window is a bit of a challenge. And all of these code libraries were written in C or C++, correct? So we actually had to write wrappers around this initially. C isn't a natively supported capability, so we wrote Node.js wrappers around that to be able to call into the native C functions to actually run as a native C solution. So it was more of kind of learning how to work within the limitations than there was with, hey, this thing isn't working like we anticipated. And then finding, with it being a brand new service at AWS, finding the documentation, finding the best practices, learning how to secure it. When these things are initially introduced into the market, Amazon sort of has a philosophy of minimal viable product. So it's what it takes to be able to be viable in the market. So it's usually fairly limited in its capabilities. But what we've seen in the last 6 to 9 months in terms of new capabilities, new services, performance enhancements, and all of that has been unbelievable.
So we're using this for large-scale batch processing, and certainly this is first use case. So there are certain batch processing capabilities that we would like to add to Lambda. And so we are working with AWS to further improve the product. And there are, people familiar with traditional batch processing. There are certain like job queues and very fine resource control. All these things can be addressed, but we wish that actually we're working with Lambda to hope that we offer this kind of service instead of we write some code to control it.
Great. We're going to be here afterwards too, so I don't want to keep people from lunch, but we'll take one more question and then.
Error recovery. So you mentioned you use S3. So obviously S3 is a not reliable service in the sense that you have to do an exponential backoff if you don't get a get or put response.
Correct.
Did all that logic get put in your Lambda functions, or did you basically say, well, if the job didn't succeed, we'll reap it later and rerun it?
That's exactly what we did, because it's not something that sequentially has to succeed for the next thing to run. You can queue up all of the errors and then go back and do a cleanup on that. The question was around S3 having some exponential backoff requirements when you're writing massive amounts scaling out to S3. Did we bake that into the Lambda function? We could have, we didn't. Well, great, thank you guys. Appreciate your time.